morning, all of you students. So today we can continue the topic in physics, that is system of particles and rotational motion. Okay. So yesterday we have learned some definitions about the system of particles and the rotational motion which we required. Today we can continue the topic of center of mass of two particle system, because yesterday we have learned about the center of mass. What is exactly center of mass? Center of mass is the point where total mass of the system is supposed to be concentrated to study the motion of particle according to the law of Newton's laws of motion. So now, once you got the idea about that center of mass, so that is a particularly point where whole mass is supposed to be concentrated. So how we can calculate actually that center of mass for two particle system, and then we can come to the n number of particle systems. Okay. So now you consider here, I have drawn one plane, because in plane there are the x-axis, this is the x-axis and y-axis, and I have considered one system which is made up of only two particles. Can you see here? Particle number 1, that is P1, and particle number 2, that is P2. Having the masses is supposed to be M1 and M2. Okay. And this O is the center of that plane. And this first particle lies at a distance of R1 bar. So that is called as the position vector of particle P1. What do you mean by position vector? A vector which gives the position of the particle in an coordinate system from the origin, that is called as the position vector. So therefore R1 bar is the position vector of first particle, and you can see the second particle P2 having the mass M2, having the position vector is supposed to be R2 bar. Okay, so therefore R2 bar is the position vector of second particle from its origin. Okay. Once you got that, how that system of particle is made up of, that particle is made up of, that system is made up of two particles, and these particles are joining with the straight line. Okay, so their center of mass must be lies on that point. So therefore RCM will be the position vector of that center of mass. So how we can find out that position vector of center of mass? So RCM will be position vector of center of mass can be calculated by using the formula M1 into R1 bar plus M2 into R2 bar upon M1 plus M2. Okay. So what is the meaning of that statement, sir? What is that formula? So position vector of center of mass means center of mass must be lies in between that 2 points, and that point we are calculating. So position vector of center of mass will be M1 R1 bar plus M2 R2 bar upon M1 plus M2. This is nothing but weighted average of position vectors of the particle from which the system is made up of. Okay, so there are how many particles are there? Two particles are there, and from that two particles system is made up of, and so therefore our position vector, our center of mass can be calculated by using this formula. If I modify this formula further, so I can write down this formula as RCM into M1 plus M2 is equal to M1 R1 bar plus M2 R2 bar. Okay. So what this point indicates, or what this equation indicates? This equation states that the position vector of center of mass and the product with the total mass of the system is same as the sum of product of individual mass and their position vectors with their position vectors. So that will be your meaning of that statement. Okay. Once you got the idea about that RCM, then we can also calculate RCM if M1 is equal to M2. Then how we can write out center of mass? Center of mass can be written as M into R1 bar plus M into R2 bar upon M plus M. And if I will take common M, so then here R1 bar plus R2 bar divided by 2m, and m get cancelled. So therefore R1 bar plus R2 bar upon 2, that will be the center of mass of that system. Okay, so what is the meaning of that RCM? If the mass is the same, if both the particles have the same mass, then center of mass must be lies at its center, R1 bar plus R2 bar upon 2. Okay, so you remember that is also one of the formula for calculating the center of mass of the system. Okay, once you got the idea about that center of mass means what and how the center of mass is lies. Now if I can consider, suppose these two particles have the coordinate x1 y1 and second particle having the coordinate x2 y2, then I will be able to find out the center of mass for that particle along the x-axis and along the y-axis. So along the x-axis, if I want to find out the center of mass or coordinate of center of mass along the x-axis will be m1 into x1 plus m2 into x2 upon m1 plus m2. Okay, means the mass of first particle into coordinate of first particle, x coordinate of first particle. Similarly, plus m2 coordinate of mass of the second particle into coordinate of second particle, that is x2, and total mass of the system. That will gives you the x center of mass. If I want to find out similarly y center of mass, so then answer will be m1 y1 plus m2 y2 upon m1 plus m2. Okay, so as there are the two particles are there, so therefore that center of mass can be written as like this. So if it would have been that is plain, then I would have been written z center of mass is equal to m1 z1 plus m2 z2 upon m1 plus m2. Okay, so this is for the two particle system. If suppose this particle instead of two, that means particles, if this system would be made up of n number of particles, so there are n number of position vectors we have been drawn for that particles m1, m2, m3, m4 and so on. So then how the center of mass can be written as? So R center of mass can be written as m1 r1 bar plus m2 r2 bar up to dash 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 mn rn bar upon m1 plus m2 plus m3 up to dash dash mn. Okay, so that will be the formula for n number of particle system. The that system is made up of n particles. Okay, so for that n particles, formula will becomes like this: m r1 bar plus m2 r2 bar plus mn rn bar upon m1 plus m2 plus up to dash dash mn. Okay, so now if I want to calculate, so that in short the position vector of center of mass, that can be written as m I r I, where I varies from 1 to n and divided by total mass of the system is supposed to be m. Okay, if suppose now I want to write down the same thing, if the coordinates are m1 x, that is x1 y1, x2 y2, x3 y3 and so on, so then that center of mass for that particle can be written as x center of mass can be written as m1 x1 plus m2 x2 up to dash dash mn xn divided by m1 plus m2 plus m3 up to dash dash mn, and total, that is center of mass, can be given as, that is equal to m1 x1 m2 x2 should be summation of mi xi, where I varies from 1 to n divided by total mass of the system. Okay, so that will be the your formula. This formula can be further, I will write down 1 upon m into, in terms of integration techniques, that will be x into dm. Okay, so we can write down this formula is like this. Similarly, if I want to write down y center of mass, then this formula will becomes, that is m1 y1 plus m2 y2 up to dash dash mn yn divided by m1 plus m2 up to dash dash mn. And so therefore this system, that point will becomes like this. I will rub this point. So therefore this formula will becomes now like this: y center of mass is equal to summation of mi yi upon, that is total mass of the system. Okay, So that will be the point where I varies from 1 to n. Or this formula can also be written as 1 upon m integration of y into dm. Similarly, if it would have been z axis, then my formula will be z center of mass is equal to summation of mi zi upon m I varies from 1 to n, that is equal to 1 upon m integration of that is z into dm. If it would have been the z axis, means this body who is in the, that is in the space. Okay, we are discussing about the plane, so therefore it has only x center of mass, y center of mass. Okay, so this is all about the position vector of that means center of mass of the body that we have calculated, their x coordinate, y coordinate that we have calculated. But now suppose I want to find out the position vector, or instead of position vector, velocity vector of center of mass. So if I will consider v1 be the velocity vector of first particle m1, v2 be the velocity vector of second particle having the mass m2. So what will be the center of mass of velocity? Velocity vector of center of mass. How we can say velocity or center of mass of VCM of velocity of center of mass can be written as m1 v1 bar plus m2 v2 bar up to dash dash mn vn bar if there are the n number of particles are there. If there are n number of particles are there. So therefore I can say that is your velocity of center of mass. Velocity of center of mass can be written as so that is m1 v1 bar plus m2 v2 bar plus mn vn bar upon total mass of the system, means m1 plus m2 up to dash dash mn. Okay, up to dash dash mn. So now here in that case, so velocity of center of mass can be written as m1 v1 bar plus m2 v2 bar upon total mass of the system. But if it would have been two particle system, then that formula would have becomes m1 v1 plus m2 v2 bar upon m1 plus m2. Okay, so that will be the your formula. So for n particles of system, suppose I want to write down this formula. So velocity of center of mass can be written as summation of I varies from 1 to n mi vi upon total mass of the system. Okay, so this is the velocity of center of mass. Now once you got that idea about the velocity of center of mass, then we want to learn about acceleration vector of that center of mass. Okay, suppose if I will consider, okay, a1, a2, a3, a1 and a2 be the acceleration vector of particle m1 and particle m2. So therefore acceleration vector of ACM can be written as m1 into a1 bar plus m2 into a2 bar up to dash dash mn into an bar upon m1 plus m2 plus m3 up to dash dash mn. Okay, so this formula can also be written as summation of I varies from 1 to n mi ai upon that is the total mass of the system. Okay, so this is the one formula, and if I want to write down for two particle system, that formula would have been written as m1 a1 bar plus m2 a2 bar upon m1 plus m2. Okay, so these are the velocity acceleration vectors of that center of mass can be calculated. Okay, tomorrow we'll see the next point, that is the momentum conservation and center of mass of the system, and then numericals also on that formula. Okay, tomorrow we'll see that. Today we'll stop.